Okay, hello everyone. In this lecture series, we are discussing approximation methods. Last class, we discussed proof of variational method. This one in detail we have been discussed. Okay, here expectation value of Hamiltonian of a system is always greater than that of the ground state energy. That we have been proved in our last class. For a particular question, suppose given in your exam, how to solve this? These are the steps or procedure to solve a question given in your exam. First, we have to write the Hamiltonian, then consider the trial wave function. If not given, we have to construct, calculate the expectation of Hamiltonian, then apply the minimum condition on expectation of Hamiltonian. So how to do that? For that, in today class, we are going to discuss this question number 1, in which we are going to discuss variational principle. Use the variational principle to evaluate ground state energy of the 1D linear harmonic oscillator using trial wave function. Here trial wave function given psi equal to c into e to the power exponent to the power minus ax square, where a is a parameter and c is the normalization constant. Okay, so to solve this question, we have to follow this procedure or these steps. First, we have to write the Hamiltonian. So for this question, Hamiltonian of 1D harmonic oscillator is nothing but kinetic energy part plus potential energy part. This is the kinetic energy part, this is the potential energy part. So kinetic energy is nothing but one dimensional. Suppose it is moving along x-axis like this. Suppose this is your 1D harmonic oscillator. If I drag it and leave, then it will oscillate about its mean position. So if it is along x-axis, so this will called as one dimensional harmonic oscillator, and its corresponding kinetic energy will be written as px cap square. This is the momentum operator square by 2m plus half kx square. That we know. This is the potential energy part, right? And this can also be written, this potential energy part can be written also as like this, half m omega square, because k is nothing but m omega square x square. Okay, now px momentum operator, that we know, minus I h cross del by del x. So square of this one, so it will be how much? Minus h cot square by 2m del square by del x square, plus as such I have been written over here. So this is your equation number 1, which represents the total Hamiltonian of this system. Here first step, write the total Hamiltonian or write the Hamiltonian of the system. So this is the Hamiltonian of the system, or you can say 1D linear harmonic oscillator. Now next step is that consider the trial wave function, then normalize it. In the question itself, it is given this one, trial wave function is this one, c e to the power minus a x square. So here this trial wave function is not normalized. First we have to normalize this trial wave function. So trial wave function given as this one, then we are going to normalize, means we have to find out the normalization constant. If I am going to normalize this one, so normalization condition is nothing but minus infinity to plus infinity integration psi star psi dx, or you can write like this by Dirac notation, by this bracket psi equal to 1, right? You just put the psi and psi star value over here. See, psi given as c e to the minus x square. So psi star obviously will be this much, because only c star we are going to consider. Psi star will be c star e to the minus ax square, but because there was no इमेजिनरी पार्ट इसमें कुछ है नहीं. सो इसका जो तुम्हारा साई स्टार क्या हो जाएगा, सी स्टार ई टू दर माइनस ए एक्स स्क्वायर. सो साई स्टार साई, इफ आई एम गोइंग टू मल्टीप्लाई, देन सी into c star is nothing but your c mod square minus infinity to plus infinity, e to the minus ax square into e to the minus ax square will be equal to e to the minus 2ax square dx equal to 1. Okay, that implies c mod square. Here this integral can be written like this. Here हियर 1 इज देयर, 1 के बदले मैं लिख सकता हूं क्या, x टू द पावर 0, x टू द पावर 0 into e to the minus 2x square dx equal to 1. Why I written like this in this format here? Because I have to apply the gamma function. According to gamma function, always you have to remember, this is important, this is important integration that you have to always remember, because this integral required बहुत जगह में वो चाहिए, required many places in your physics, in derivation as well as different questions, to solve the different questions. So here in general, minus infinity to plus infinity x to the power n e to the power minus a x to the power m dx, for n is even, if n is even, then whole integral will be a even function. So it can be written as 2 into 0 to infinity e to x to the power n e to the minus a x to the power m dx. Here I written for n equal to even. See, if n equal to odd, no, if n equal to odd, then whole integration value will be 0. That is the separate thing. Here x to the power n, if n is even, then this integral can be written as 2 into 0 to infinity x to the power n e to the minus x to the power m dx. Now this integral value in general, you just remember, the value will be 1 by m into 1 by a to the power n plus 1 by m into gamma n plus 1 by m. This is the most important that you have to remember. If I am going to compare this integral with this one, so n value is how much? 0. A value is how much? 2a. M value is how much? 2. So that implies c mod square as such I written. So this integral can be written as 2 into 0 to infinity. Again I written, okay, again I written this one, 0 to infinity x to the power 0 e to the power minus 2x square dx equal to 1. And this integral value will be how much? 1 by m. Here you can see 1 by m. M is nothing but your 2. 1 by 2. Then 1 by a to the power n plus 1 by m. A is how much? 2a. 2a to the power n plus 1. N is how much? This one, 0. 0 plus 1 by 2. 0 plus 1 by m. 0 plus 1 by m. 0 plus 1 by m. M is how much? 2. 2. So 1 by 2. 1 by 2 are written. Then gamma n plus 1 by m. Gamma half. Gamma half value we know root pi. Right? So this value, just to simplify, the c mod square into here 2 got cancel. Okay, 1 by 2a to the power 1 by 2. This value is nothing but, gamma half is nothing but root pi equal to 1. That implies c value we found 2 by pi to the power 1 by 4. Now the normalized trial wave function, here the trial wave function given as a c into this much, e to the power minus a x square. So c value here we found, the value is how much? We found 2a by pi to the power 1 by 4. So normalized wave function will be 2a by pi to the power 1 by 4 into e to the power minus a x square. Let this is your equation number 2. Now हमारा दो जो स्टेप्स वो अभी खत्म हो गया. नेक्स्ट स्टेप में करना क्या है? कैलकुलेट द एक्सपेक्टेशन ऑफ हैमिल्टोनियन. वी हैव टू कैलकुलेट द एक्सपेक्टेशन. सो थर्ड स्टेप, एक्सपेक्टेशन वैल्यू ऑफ h cap for the state psi. Okay, so the expectation of Hamiltonian will be written as this one, psi. This is the bracket notation or Dirac notation, and this is your integral format. So here psi star h cap psi dx whole divided by psi star psi dx minus infinity to plus infinity. As psi is the normalized wave function, so this value will be equal to 1. Okay, so this value no need to calculate again, because here we are going to use the normalized wave function. Okay, so now the numerator only we have to write here psi star h cap psi dx minus infinity to plus infinity psi star h cap. H cap means Hamiltonian operator. How much we have that one, minus h cross square by 2m d square by dx square plus half m omega square x square. Same as such written over here, psi dx. Okay, just segregate by two integrals here, for this one integral, for this one another integral. So psi star minus h cross square by 2m d square by dx square psi dx, and another integral will be minus infinity to plus infinity psi star this much half m omega square x square psi dx. Okay, okay. Now psi star minus x cross square by 2m d square by dx square. Here psi value or normalized wave function, how much we found? 2a by pi to the power 1 by 4 e to the minus a x square. that I have been written over here. Okay, dx plus half m omega square psi star is there. See, half m omega square is a constant taken outside of the integration, minus infinity to plus infinity, minus infinity to plus infinity. This is psi star x square, here x square psi dx, right? Right. Now you have to differentiate this term by 2 times with respect to x. अगर तुम differentiate करोगे तो क्या मिलेगा? ये इतना ही मिलेगा, 4a square x square minus 2a into psi. Psi means 2a by pi to the power 1 by 4 e to the minus a x square. वही मिलेगा. Okay, you do it in your rough. Now multiply this minus s cross square by 2m with this one and remove this bracket, then we can get the two terms here. Psi star, if I'm going to multiply minus h cross square by 2m into minus 2a, then it will be plus 2a h cross square by 2m psi star psi dx. Then multiply this one minus h cross square by 2m 4a x square and psi star psi. So it will be minus h cross square by 2m 4a square is a constant taken outside, minus infinity to plus infinity, x square is a variable, so it will be inside the integral. Psi star x square psi dx plus half m omega square minus infinity to plus infinity, as such I have been written over here. Okay. Okay, next, in the next step, here you can see this value psi star psi as this is the inner product, minus infinity plus infinity psi star psi dx. That means this value is your 1 because we these are the normalized wave functions. So how much we can found? First term 2 got cancel, h cross square a by m. Okay, then here you can see this integration and this integral both are same. So if I'm going to take common from these two terms, then first term will be here 2 got cancel, so it will be the numerator will be minus 2a square h cot square 2 h cot square a square, okay, by m plus this one half m omega square, because this integration is the common for these two terms. I written over here minus infinity plus infinity psi star x square psi dx, right? Right. So as such this term written over here, this one psi star value psi star x square psi, right? Or we can write there is no differentiation, so x square psi star psi. If I'm going to consider psi star into psi value is how much? This one. Normalized wave function value is this one. Okay, if I'm going to multiply psi star is nothing but also same 2a by, there is no imaginary terms, imaginary term कुछ है नहीं, तो वो उतना ही आएगा. तो if I'm going to multiply both psi and psi star, so it will be 2a by pi to the power, ये कितना है 1 by 4, ये भी 1 by 4, so ये 1 by 2 हो जाएगा, e to the minus 2a x square हो जाएगा सिंपली. सो वही चीज मैंने यहाँ पे लिखा है x square as such written. So psi star psi value is 2a by pi to the power 1 by 2 e to the minus 2a x square dx. So this term written as such, then this term also here 2a by pi to the power 1 by 2 taken outside, and here minus infinity to plus infinity, see x to the power 2 is the even. So this integration can be written as 2 into 0 to infinity x square e to the minus 2x square dx, right? Right. Now this integration value in general what we know, in general this type of integration value is what? This one. I told that you have to remember always this one minus 1 by m a to the power 1 n plus 1 by m gamma n plus 1 by m. So this integration value always 1 by m into 1 by a to the power n plus 1 by m gamma n plus 1 by m. Okay, so here m is nothing but, see in general how we have to write x 0 to infinity x to the power n into e to the minus a x to the power m dx, right? So if I'm going to compare with these two integrals, so here a value is nothing but 2a, okay, m value is nothing but 2, n value is 2. So 1 by m means 1 by 2, okay, 1 by a to the power n plus 1 by m, 1 by a means how much? A is your what? A is your 2a, here a is your 2a to the power n plus 1, here n is your 2 plus 1, 3 by m, 3 by 2 gamma 3 by 2, right? Same this term written as such 2 by pi, sorry 2a by pi to the power 1 by 2 into 1 by, here 1 by 2 2 got cancel, 1 by 2a to the power 3 by 2 uh, here gamma 3 by 2 is nothing but half root pi, because gamma 3 by 2 can be written as half gamma half, because gamma n plus 1 is nothing but n gamma n. So gamma 3 by 2 can be written as gamma 1 by 2 plus 1. So only for that it can be written as half gamma half. Okay, maybe you know about gamma function well. I just told, may you forgot. Okay, so this term written as such. So here um, here you just solve it, here 2a got cancelled, but here 1 by 2 is there, 3 by 2 is there. Okay, and here see root pi got cancelled. If this will be moved up, so 1 by 2 minus 3 by 2, so it will be how much, minus 1 by 2, right? Minus 1 minus 1 minus 1 by 2 minus 3 by 2, so it will be minus 1. Okay, minus 1 means 2a. 2a will be the in the at the will be at denominator, 2a into 2, so it will be 4a. Then after simplification we found expectation of Hamiltonian is nothing but this one, h cot square a by 2m plus 8a into m omega square. Let this is your equation number 3. Here si is the function of the parameter a. So here parameter a, uh, parameter a we have in the equation number 3. That means expectation value of Hamiltonian is the function of a. Now we are going to use the third step, calculate the expectation value. Third step to ho gaya, third step completed. Then apply minimum condition. Minimum condition means what? Minimization of expectation value of Hamiltonian with respect to a. That means differentiating expectation value of Hamiltonian with respect to a and equating to 0. That means if this is minima or maxima with variable a, then if I am going to differentiate with respect to a this value and equate to 0, then I can found the a value. Okay, this is the general minimization condition, minimum condition. Okay, so to evaluate the a value, what I have to do? I have to differentiate this expectation value with respect to a. You just differ and equate to 0. So first term differentiate with a, it will be h cot square by 2a. Second term differentiate with respect to a, it will be minus m omega square by 8a square, because here it is 1 by a means minus 1 by a square. Differentiation if I am going to do with respect to a equal to 0. After simplification we can found the a value is your m omega 2h cross. M omega 2h cross. Let this is your equation number 4. Okay, now whatever the a value we found over here, we have to just put in equation number 3. In equation number 3, that means our expectation value, general expectation value of a arbitrary wave function, that is your equation number 3. In equation number 3, if I will put this a value here, h cot square by 2m, h cot square by 2m into a means here m omega by 2h cot plus 1 by 8 a was there, m omega by 2h cot m omega square. Just simplify it, you can found half h cot omega, which is nothing but your ground state energy of 1D harmonic oscillator. So here by using this trial wave function, we exactly found the ground state energy of linear harmonic oscillator, this one. Here in the question itself it is given that the trial wave function we have to consider this one. Sometimes this trial wave function will be given like this. Suppose c into e to the power minus a x क्यू प्लस x, ऐसा कुछ होगा. तो कुछ भी दिया होगा तो उसको नॉर्मलाइज करते हुए, इस प्रोसीजर फॉलो करते हुए जितना आएगा वही तुम्हारा फाइनल आंसर होगा. दैट विल बी योर फाइनल आंसर. बट हियर as per the trial wave function what we calculated, the ground state energy of linear harmonic oscillator, it is exactly matched. That means this is the the trial wave function whatever given in the question is the exact match with the ground state wave function. So ground state wave function will be what? Ground state wave function. So here trial wave function after normalization from equation number 2 we found this one. Now we have to put the value of a. Value of a is nothing but m omega by 2h cot, m omega by 2h cot. So by substituting this value, this will be your ground state energy, ground state eigenfunction of linear harmonic oscillator. Okay, if I'm going to put m omega by pi h cot as alpha square, so it will be alpha square by pi to the power 1 by 4 into e to the power alpha square x square by 2. May you have been studied in your plus 3 when you derived and you found the ground state energy means psi 1 value for linear harmonic oscillator. So here we found the same. Okay, so here we discussed in this video in detail about finding the ground state eigenvalue and eigenfunction of a linear harmonic oscillator step by step. Okay, in our next class we are going to discuss question number 2, that is use the variational principle to estimate the ground state energy of hydrogen atom. Here given the trial wave function as this one, c e to the minus ar, a is the parameter and c the normalization constant. So here we are going to consider the 3-dimensional picture. Okay, that we are going to discuss in our next class. Okay, thank you so much for watching this video. Thank you.